Hello everyone, welcome to Nalanda EDvantage. Here is another video for you. So today we will be learning about magnets. We're going to learn about the discovery of magnets, types, the properties of magnets. We'll learn about magnetic and non-magnetic materials, and lastly, the ways to store a magnet. So let's quickly start. What is a magnet? A magnet is a material that has a property of attraction to pull the ferromagnetic materials such as your iron, cobalt, nickel. You have seen magnets, or you must have observed magnets in your everyday life, such as those beautiful souvenirs that you had, that you bring from places you visit and you place it on your refrigerator doors. All these are magnets. Your handbags, they have a magnetic lock, and various types of magnets available in our day-to-day gadgets and appliances. So let's learn about how it has been discovered. Now, there's a story that a shepherd from the island of Crete in Greece was first to discover the lodestone when his crook, which was a long rod which has an iron tip towards it, was pulled towards a stone when he was passing over it. The name of the shepherd was Magnus. This rock was made of magnetite which contained iron. And this came to be known as the first natural magnet, and the stone name was lodestone. Now let's see how many types of magnets are there. So there are two types of magnets, natural and artificial. In the previous slide we have learned about the natural magnet, which are made up of magnetite and they are found in nature. Now, artificial magnets, they are prepared using various processes and with the help of iron. Few examples of different shapes and varieties available in artificial magnets are horseshoe, bar magnets, cylindrical and ball-ended magnets. As you can see in the figure here, there are various artificial magnets in beautiful color and designs. Now, there is one property also. Natural magnets and artificial magnets, they varied in their strength. Natural magnets are less, you can say less stronger than your artificial magnets. Whereas your artificial magnets, they are more powerful when they are compared with the power or ability to pull off the iron or magnetic substances towards it. And your artificial magnets, they are available in variety of shapes, colors and sizes. Next we are going to learn about is the poles of a magnet. Now, your magnet such as a bar magnet or any kind of magnet that you are taking, it consists of two poles. For reference point, we are naming them as a north pole and a south pole. In the figure here, you can see they are represented as N for North Pole and S for South Pole. These ends are called as poles, and usually they have a stronger magnetic field around them compared to the rest of the magnet. So if we are going to have an experiment, suppose you are going to put iron dust near the table or a paper, and you're going to move the bar magnet over it, you will find that most of the iron dust or the iron pins, they cling towards your poles of a magnet, thereby declaring that poles of a magnet are stronger than compared to the rest of the magnet. In those nearby lines, as you can see in the figure here, these are known as magnetic field lines. So the area generated nearby the magnet and the magnetic force of attraction, these are known as magnetic field. Anything which comes nearby this magnetic field gets attracted, automatically pulls towards this magnet. Now, very important thing we need to learn is that poles of a magnet, they cannot be alienated, which means you cannot ever, separate the poles of a magnet. The poles of a magnet will always remain or stick together. You will always find a north pole or a south pole. Even if you are going to break a bar magnet into two pieces, the remaining two pieces will automatically have a north pole and a south pole. Similarly, if you're going to cut the pieces again into the two, now you have 4 magnets. So all those 4 magnets are going to have separate 4 poles comprising of both north pole and a south pole. So it is impossible to alienate a magnet. Now, let's see the properties of a magnet. The first property is about attraction and repulsion of a magnet. We know that there are 2 poles of a magnet, north pole and a south pole. The rule says that like poles or the same poles of 2 magnets, when they are brought together, they repel each other, right? So that means if you are going to bring the north and north or the south and south, you will find they are going to repel each other as given here in the diagram. Whereas if you are going to bring 2 unlike poles, that means north pole or south pole, or vice versa, south pole and a north pole together, they are going to attract towards each other. So as a rule of thumb, we're going to remember this property that like poles repel and unlike poles attract each other. Now, one major aspect of attraction or repulsion is it is going to identify the magnet. What happens is there are different kind of materials also, such as various iron based materials that will attract a magnet, and a magnet also will attract a magnet if it is based of unlike poles. So how we are going to differentiate between those two? Then the property of repulsion comes in the factor, because only the magnet can repulse another magnet, but any iron based object is always going to attract towards a magnet. So this property makes a difference, or if you want to identify between the magnetic based substances and a real magnet, so the property of repulsion is going to help you. Let's see the important application of magnet using the second property. The second property states that a freely suspended magnet will always come to rest in a north and south direction. From ancient times, to identify directions, whenever a person is going in different places, or you're on adventure trips, earlier times the magnetic compass is used to find out the directions. Now, what is a compass? Compass is a device used to find directions. It consists of the magnetic needle as shown in the diagram here, a dial marked with the directions with a glass cover. This glass cover is very important because it is a non-magnetic substance. Hence, it will not give you wrong directions. The freely rotating needle comes to rest in a north-south direction as it is depicted on the dial. And as you can see on the dial, the needle is marked with a red color, which is nearly almost points towards the north pole of the magnet. Now we have been talking about magnetic and non-magnetic materials. So let's quickly see what are these. So any material which gets attracted towards magnet, they are all magnetic materials. Few examples are your nickel, iron, cobalt, right? But all the metals, they are not attracted towards a magnet. Few examples are your silver, gold and aluminium, which are non-magnetic. That means they will not attract towards the magnet. And few non-magnetic materials, that means they do not get attract towards a magnet. So there are various examples such as rubber, glass, paper, plastic and wood, etc. Now one last thing is how to store your magnets so that they can be used for prolonged time. Now various precautions needs to be taken care when you are using a magnets. So these magnets, they lose their magnetism whenever they are heated, hammered or dropped from some height, right? They become weak if they are not stored properly. So what are the various ways to store them? So the ways here given here as depicted in the figure here, you can see your bar magnets, they should be kept in pairs. Okay, they should always be kept in pairs with their unlike poles on the same side. That means north and south towards each other and south and north towards each other. And they must be separated by a piece of wood. This piece of wood or a wooden board is also known as keeper. In some books, you will find the name keeper. And they are sealed over with an iron bar. So this keeps the magnetic property intact. This is how your bar magnet should be stored. But if you have a horseshoe magnet, such as this U-shaped magnet that you can see in the second diagram, you should keep a piece of iron across the poles, right? So that means all the unlike poles are already together and then they are sealed with an iron bar. And you need to store your magnets away from your cassettes, mobiles, televisions, music system, CDs and computer. That means all the electronic devices, it should be refrained and it should be kept away from them. This is how you're going to store your magnets, and for a longer time you are going to use them. So I hope this video was really helpful for you. Let's take a quick quiz and see how much we have learned. So the question number 1 here says, magnets have a shape. Is it cylindrical, ball-ended, horseshoe, or all of these? So definitely students, the answer here is all of these, and all of these are your artificial magnets, because your artificial magnets can be made in variety of shapes. Question number 2. The magnetic property of a magnet cannot be destroyed by hammering, heating, boiling on a hard surface, or boiling. The answer here is boiling, because you know hammering, heating and dropping always loses its magnetic property. Question number 3. Now you have to identify the wrong statement given here. The statement A is, heat can destroy magnetic property of a magnet. Magnets are made of different materials and different shapes. C, there is maximum attraction in middle of a magnet. Magnetite does not show magnetic properties. So among these, the wrong statement here is definitely D. Magnetite does not show magnetic properties, because magnetite, as we know, is a natural magnet and it definitely shows you magnetic properties. Question number 4. You have to choose the correct statement. When a bar magnet is brought near iron dust, most of the dust sticks. So this part we have taken in the video previously also, and this was the experiment that I was talking about. So students, if you are placing iron dust near the bar magnet, most of the dust sticks in the ends of a magnet, also known as the poles of a magnet. So these were the few simple questions. I hope the video was really helpful for you to understand the chapter Fun with Magnets. Students, always train your mind. Your mind is like a magnet. If you think of the blessings, you attract blessings. If you think of the problems, you will attract problems. So positive thinking is the key to be optimistic and get what we want from the life. Thank you so much for watching. Please subscribe the channel and share, like and comment your thoughts so that your valuable feedback can help us to improve. Thank you so much for watching Nalanda EDvantage.